the body has a really, really cool way of controlling blood pressure. And you'll hear about this RAAS system. And RAAS stands for renin-angiotensin, RA, aldosterone system. So let's go through this RAAS system kind of as an overview, just looking at where things start from and where things go in terms of cells and hormones. So those are the two things I want to try to distinguish between. So this RAAS system, RAAS, it begins with a set of cells. So I'm going to draw all of my cells as little blue houses like that. And the hormones that they release are going to be orange messengers. So I'm going to draw a little messenger. This will be my little person. And so the person is the hormone, and the blue house is the cell. Now, the key cell in the RAAS system is the juxtaglomerular cell. So JG cell. And these juxtaglomerular cells are actually in the kidney, but they're in a specific location. They're actually in blood vessels. And if you look closely, these JG cells are nothing more than very special smooth muscle cells. So if you look in the blood vessel, they're actually just like smooth muscle cells. So I'm going to write smooth muscle just to remind you. This is just a reminder of where they are. And of course, these are in the kidney. So here's my little kidney. It may not look like a kidney, but that's what it's supposed to be. So the juxtaglomerular cells are releasing a hormone called renin. And when would they do that? Well, renin is eventually, we'll see when, eventually going to help us raise blood pressure. So if the juxtaglomerular cells, if these little guys notice that blood pressure is low, that would be a trigger for releasing renin. That's the first trigger. So low blood pressure. Very good. Now, that's not the only trigger. There are actually 3 triggers in total. So let me write out 2 and 3, and let's go through what they are. So the second trigger is a neighboring cell. So this neighboring cell is actually a sympathetic nerve cell. And we know that sympathetic nerve cells, they fire whenever something big is going on. So for example, let's say you're running away from a bear, or let's say you're trying to win a fight, or let's say you're in a car accident and you're bleeding. Any sort of major stressor is going to cause these nerve cells to start firing. And when they fire, that JG cell starts releasing renin. So the second trigger would be sympathetics. I'll just write sympathetics, or maybe sympathetic nerves. Now, if these are your neighboring cells, these little sympathetic nerve cells, because they literally end right on the JG cells, then a little ways away, still in the kidney, of course, but still a little ways away, not touching the JG cells, would be the macula densa cells. Macula densa cells. Now, stay with me for this. So these macula densa cells are also in the kidney, and actually they're in the distal tubule of the nephron. So remember the distal convoluted tubule. They're there, and their interesting ability is the ability to sense sodium. And when you have low blood pressure, not a lot of blood is moving through that glomerulus, and so not a lot of fluid is moving through the nephron as a result, and a lot of the salt is being reabsorbed. So by the time it gets to that distal convoluted tubule, the macula densa cells, they're kind of tasting or sensing the fluid that goes by, and they say, there's not a lot of salt here. And they put 2 and 2 together, and they realize that the reason there's not a lot of salt is that blood pressure is low. So when they don't sense much salt, they say, hey, JG cells, wake up, do something about this, raise blood pressure for us. And so they send a message over in the form of prostaglandins. So prostaglandins are kind of local messengers. unlike renin, which is kind of a long-distance messenger, prostaglandins act locally, and actually lots and lots of cells in our body use prostaglandins to send local messages. So that's what they do. So the third trigger, just to summarize it, would be low salt in the distal convoluted tubule. And you know specifically that it's the macula densa cells that pick up on this convoluted tubule. Okay, so these are the three major triggers for renin release. And now this is all happening in the kidney, right? That's where all this action is occurring. But you know there are other organs involved in blood pressure control as well. And the one that is next on our list is the liver cell. So liver cells are actually, here we go, a little house for cells, are also making a hormone of their own. And it's going to meet up with renin in a second. And it's called angiotensinogen. Angiotensinogen. And angiotensinogen is kind of like a sleepwalker. If you were to zoom in on its face, it would be asleep. And so I'm going to draw it that way. It's there and it's moving around the body, but it's not active. And that's the key thing. It's not active. But it meets renin, and renin literally chops off a big hunk of angiotensinogen. And if that doesn't wake you up, I don't know what would. So angiotensinogen becomes angiotensin 1. Angiotensin 1. After meeting renin. So renin is an enzyme that cuts a big chunk of this angiotensinogen protein away. And angiotensin 1 is the result. And if you were to zoom in on this guy's face, it would be awake. Maybe even a little smile. So angiotensin 1 now floats through blood vessels. And of course, blood vessels have cells lining them. So let's draw a little house. So little cells, and these are the endothelial cells. So these are the cells that are lining the blood vessel on the inside. And classically, we used to think that this is almost always happening in the lungs, but more and more realizing that it definitely does happen in the lungs, but it's in other places as well, other vessels as well. And so endothelial cells in a number of parts of our body, including the lungs, are able to convert angiotensin 1 into angiotensin 2. So angiotensin 2 is formed. And this is also, of course, a hormone. So I'll draw it as a little person. And angiotensin 2 is happy as a clam because angiotensin 2 has lots of activity. Very, very active hormone. Does all sorts of things. And I'm going to draw them in for you now. So angiotensin 2 will go out to a number of different places. I'm going to draw 4 arrowheads here. 1, 2, and then 2 in the middle here. 3, let's do 4. And so it goes to 4 places, and 4 different cell types are affected by angiotensin 2. Now keep in mind, at the beginning of all this, we're trying to raise blood pressure. So just keep that thought in your head. So 4 different cell types are affected, and here is the 4th. So the first one over here is smooth muscle cells in the blood vessels. So smooth muscle cells, and this is blood vessels all over the body, not just in the kidney, but this is smooth muscle cells all over the body, are going to contract. They're going to constrict down, and they're going to cause increased resistance, because you remember that as the blood vessels constrict, vasoconstrict, that will increase resistance. Okay, so that's one effect. Now in a different cell type altogether, in the kidney cells, you actually have the ability, the angiotensin 2 actually makes these kidney cells hold on to more water. So you have more volume. It actually helps the kidney hold on to more water, and more volume think about it in terms of stroke volume, is going to increase stroke volume. So you've got increased resistance and now increased stroke volume. So those are two cell types that angiotensin II will act on. It also acts on a couple of glands. So I'm going to try to draw for you the pituitary gland. And this pituitary gland is sitting at the base of the brain. And this gland is called that because it secretes hormones as well. So it's actually sending off messengers as well. So here's a little hormone, again, in orange. Remember, all our hormones are in orange. And this one is called ADH. ADH, antidiuretic hormone. And that ADH does some of the same stuff at the end of the day that angiotensin II will do, in that it will increase resistance of blood vessels, and it will actually also increase volume by making the kidney hold on to more water. Now, the fourth cell type is going to be the adrenal gland. So the adrenal gland is here, and this adrenal is called adrenal because it's sitting on top of the kidney, which is the adrenal. This adrenal gland is also making a hormone because it's a gland, and that hormone is going to act right there. And this is your little messenger, and this is called aldosterone. Aldosterone. So you've got aldosterone and ADH that are also acting on some of the same cells. And I should rephrase that, not exactly the same cells, but the same organs as the angiotensin II. So here, aldosterone is going to act on kidney cells to increase volume, and ADH is going to act on, as I said before, the kidney and smooth muscle. So let me scroll up. Let me scroll up and show you now from the top some interesting things I want to point out. So we've got, at the very top, all of the action, you'll remember, started in our kidneys, right? So it started in the kidney with the macula densa cell and our JG cell, and even our nerve endings were in the kidneys. And one of the key target organs down here is, of course, the kidney. So things are starting in the kidney and also ending in the kidney. Now you'll say, well, what about the smooth muscle cells? Isn't that all over the body? And you're absolutely right. It does also affect smooth muscle in other parts of the body. But I just want to point out the fact that the kidney is a major player in this game. Now, that's one point. The other point is that when people talk about the renin, angiotensin, aldosterone system, they're talking about certain pathways, and they're specifically talking about, for example, this arrow right here, this hormone, obviously. And they're talking about this angiotensinogen, and they're talking about angiotensin 1. And they're also referring to angiotensin 2 and all of its targets. So they're going to talk about angiotensin 2 affecting the smooth muscle and the two glands, the pituitary as well as the adrenal gland, and its effect on the kidney. So they're really referring to all of those things. So they want to make sure you remember that that it's affecting at least four target cell types, and finally that aldosterone down here has a huge effect on the kidney as well. So these are the important points to take away from this overview, that there are many different hormones involved, and I've tried to keep them color-coded all in orange to make sure we keep track of them, and the fact that the kidney is a major player in blood pressure control.